to this introductory course on SQL. SQL, or Structured Query Language, is one of the most widely used languages in the global tech industry. Data scientists, data analysts, data engineers, data warehouse specialists, business intelligence analysts, data architects, and database administrators all rely on their SQL skills to access databases, query data, or perform analysis. As companies continue to generate enormous amounts of data to support their growth strategies, the high demand for SQL skills is expected to continue. Companies hiring data scientists, data analysts, data engineers, data warehouse specialists, business intelligence analysts, data architects, and database administrators all rely on their SQL skills to access databases, query data, or perform analysis. As companies continue to generate enormous amounts of data to support their growth strategies, the high demand for SQL skills is expected to continue. Companies hiring data professionals ranked SQL the second most in-demand tech skill from a top 25 list by Burning Glass, which analyzes millions of job listings daily. SQL professionals earn a median salary of $92,504, with job growth projected at 11.5% over the next decade. SQL is a powerful language used for communicating with databases. Whether it's just a few rows in a single table, or millions or billions of rows spanning a large number of tables, SQL professionals earn a median salary of $92,504 spread across a cluster of servers. There are numerous advantages to learning SQL for anyone interested in working with data. SQL is an essential skill and will boost your professional profile as a data professional. SQL is one of the most in-demand skills by hiring employers. And learning SQL will give you a solid understanding of working with not only relational databases, but many NoSQL and big data engines that also utilize SQL-like interfaces. This course prepares you for using SQL in the real world. You will learn the basics of SQL language and relational databases. You will start with performing simple SQL queries using select, insert, update, and delete statements. Next, you will create tables and load them with data. You will then learn how to filter, sort, and aggregate results, as well as work with built-in database functions. You will also learn how to write nested queries and join data in multiple tables. And finally, you'll demonstrate your SQL skills with multiple hands-on labs and a real-world inspired project using a real-world dataset. Upon completing this course, you will have developed skills and experience composing a variety of SQL queries and using them to access and manipulate data in databases. If at any time in the course you need assistance or clarification, please post in the course discussion forums to interact with your peers and course staff. So, without further ado, let's begin your journey with SQL.
Hello! First, we will talk a little bit about what you'll learn in this course. This course teaches you the basics of the SQL language and the relational database model. There will be some lab exercises, and at the end of each section, there are a few review questions, and at the end, there is a final exam. By the end of this course, you will be able to discuss SQL basics and explain various aspects of the relational database model. In this video, we will learn about SQL and relational databases. By the end of this video, you will be able to describe SQL, data, database, a relational database, and list 5 basic SQL commands. But wait, what is SQL and what is a relational database? What is SQL? SQL is a language used for relational databases to query or get data out of a database. SQL is also referred to as SQL and is short for its original name, Structured English Query Language. So SQL is a language used for a database to query data. But what is data and what is a database? Data is a collection of facts in the form of words, numbers, or even pictures. Structured English Query Language. So SQL is a language used for a database to query data. But what is data and what is a database? Data is a collection of facts in the form of words, numbers, or even pictures. Data is one of the most critical assets of any business. It is used and collected practically everywhere. Your bank stores data about you, your name, address, phone number, account numbers, etc. Your credit card company and your PayPal accounts also store data about you. Data is important, so it needs to be secure, and it needs to be stored and accessed quickly. The answer is a database. So, what is a database? Databases are everywhere and used every day, but they are largely taken for granted. A database is a repository of data. It is a program that stores data. A database also provides the functionality for adding, modifying, and querying that data. There are different kinds of databases of different requirements. The data can be stored in various forms. When data is stored in tabular form, the data is organized in tables, like in a spreadsheet, which is columns and rows. That's a relational database. The columns contain properties about the item, such as last name, first name, email address, city. A table is a collection of related things, like a list of employees or a list of book authors. In a relational database, you can form relationships between tables. So a database is a repository of data. A set of software tools for the data in the database is called a database management system, or DBMS for short. The terms database, database server, database system, data server, and database management systems are often used interchangeably. For relational databases, it's called a Relational Database Management System, or RDBMS. RDBMS is a set of software tools that controls the data, such as access, organization, and storage. An RDBMS serves as the backbone of applications in many industries, including banking, transportation, health, and so on. Examples of relational database management systems are MySQL, Oracle Database, DB2 Warehouse, and DB2 on Cloud. For the majority of people using a database, there are 5 simple commands to create a table, insert data to populate the table, select data from the table, update data in the table, delete data from the table. So those are the building blocks for SQL for data science. You can now describe what is SQL, what is data, what is a database, and what is a relational database. You know that RDBMS stands for Relational Database Management System. And you can list 5 basic SQL commands to create a table, insert data to populate the table, select data from the table, update data in the table, and delete data from the table. Thanks for watching this video. Hello, and welcome to Retrieving Data with a Select Statement. In this video, we will learn about retrieving data from a relational database table by selecting columns of a table. At the end of this lesson, you will be able to retrieve data from a relational database table, define the use of a predicate, identify the syntax of the select statement using the where clause, and list the comparison operators supported by a relational database management system. The main purpose of a database management system is not just to store the data, but also facilitate retrieval of the data. So, after creating a relational database table and inserting data into the table, we want to see the data. To see the data, we use the select statement. The select statement is a data manipulation language statement. Data manipulation language statements, or DML statements, are used to read and modify data. The select statement is called a query, and the output we get from executing this query is called a result set, or a result table. In its simplest form, a select statement is select star from table name. Based on the book entity example, we would create the table using the entity name book and the entity attributes as the columns of the table. The data would be added to the book table by adding rows to the table using the insert statement. In the book entity example, select star from book gives a result set of 4 rows. All the data rows for all columns in the table book are displayed. In addition, you can also retrieve all the rows for all columns by specifying the column names individually in the select statement. You don't always have to retrieve all the columns in a table. You can retrieve just a subset of columns. If you want, you can retrieve just 2 columns from the table book, for example, book_ID and title. In this case, the select statement is select book_ID, title from book. In this case, only the 2 columns display for each of the 4 rows. Also notice that the order of the columns displayed always matches the order in the select statement. However, what if we want to know the title of the book whose book_ID is B1? Relational operation helps us in restricting the result set by allowing us to use the clause where. The where clause always requires a predicate. A predicate is a condition that evaluates to true, false, or unknown. Predicates are used in the search condition of the where clause. So, if we need to know the title of the book whose book_ID is B1, we use the where clause with the predicate book_ID equals B1. Select book_ID, title from book, where book_ID equals B1. Notice that the result set is now restricted to just one row whose condition evaluates to true. The previous example used the comparison operator equal to in the where clause. There are other comparison operators supported by a relational database management system: equal to, greater than, less than, greater than or equal to, less than or equal to, and not equal to. Now you can retrieve data and select columns from a relational database table, define the use of a predicate, identify the syntax of the select statement using the where clause, and list the comparison operators supported by a relational database management system. Thanks for watching this video.
Refer to illustration.
Hello and welcome. In this video, we'll briefly present a few useful expressions that are used with select statements. The first one is count. Count is a built-in database function that retrieves the number of rows that match the query criteria. For example, get the total number of rows in a given table. Select count star from table name. Let's say you create a table called metals, which has a column called country, and you want to retrieve the number of rows where the medal recipient is from Canada. You can issue a query like this. Select count country from metals where country equals Canada. The second expression is distinct. Distinct is used to retrieve a database function that retrieves the number of rows that match the query criteria. For example, get the total number of rows in a given table. Select count star from table name. Let's say you create a table called metals, which has a column called country, and you want to retrieve the number of rows where the medal recipient is from Canada. You can issue a query like this. Select count country from metals where country equals Canada. The second expression is distinct. Distinct is used to remove duplicate values from a result set. Example, to retrieve unique values in a column. Select distinct column name from table name. In the metals table mentioned earlier, a country may have received a gold medal multiple times. Example, retrieve the list of unique countries that received gold medals, that is, removing all duplicate values of the same country. Select distinct country from metals where medal type equals gold. The third expression is limit. Limit is used for restricting the number of rows retrieved from the database. Example, retrieve just the first 10 rows in a table. Select star from table name, limit 10. This can be very useful to examine the result set by looking at just a few rows instead of retrieving the entire result set, which may be very large. Example, retrieve just a few rows in the metals table for a particular year. Select star from metals where year equals 2018, limit 5. In this video, we looked at some useful expressions that are used with select statements, namely the count, distinct, and limit built-in functions. Thanks for watching this video.
Hello, and welcome to the insert statement. In this video, we will learn about populating a relational database table. At the end of this video, you will be able to identify the syntax of the insert statement and explain two methods to add rows to a table. After a table is created, the table needs to be populated with data. To insert data into a table, we use the insert statement. The insert statement is used to add new rows to a table. The insert statement is one of the data manipulation language statements. Data manipulation language statements, or DML statements, are used to read and modify data. Based on the author entity example, we created the table using the entity name, author, and the entity attributes as the columns of the table. Now we will add the data to the author table by adding rows to the table. To add the data to the author table, we use the insert statement. The syntax of the insert statement looks like this: insert into table name, column name, values. In this statement, table name identifies the table. The column name list identifies each column in the table, and the values clause specifies the data values to be added to the columns in the table. To add a row with the data for Raoul Chong, we insert a row with an author underscore ID of A1, the last name as Chong, the first name as Raoul, the email as rfc@ibm.com, the city as Toronto, and the country as CA for Canada. The author table has 6 columns, so the insert statement lists the 6 column names, separated by commas, followed by a value for each of the columns, also separated by commas. It is important that the number of values provided in the values clause is equal to the number of column names specified in the column name list. This ensures that each column has a value. Tables do not need to be populated one row at a time. Multiple rows can be inserted by specifying each row in the values clause. In the values clause, each row is separated by a comma. For example, in this insert statement, we are inserting 2 rows, one for Raoul Chong and one for Rav Ahuja. Now you can identify the syntax of the insert statement and explain the 2 methods to add rows to a table, one row at a time or multiple rows. Thanks for watching this video.